What's going on, guys? Mr. Jones coming at you once again. Today, we're going to be talking about Ready, Set, Go 5.5, and it should be pretty quick and easy, so let's just get right to it. The first one says, for each inequality and graph, pick a point and use it to determine which half plane should be shaded, then shade the correct half plane. So that sounds kind of different, right? So here's what we're going to do. First, I'm going to make this big over here, and this is problem 1, right? So I just want to point out a couple things. Here's the y-axis, here's the x-axis, and it looks like it crosses right here, right? So this is my 0, 0 right here. Okay, so 1, 2, 3, 4. I got a point right there, and that point right there is x is 0, y is negative 4, right? So I have one point there. Okay, and then another point maybe right here, right? Just so we can get an idea of where the graph is. Here's the arrow, here's the arrow. All right, so that stuff doesn't matter too much. I just want you to see where the graph was so we can start talking about it. So now it says to pick a point to determine which side it should be shaded on, right? So let's just pick the easiest point. I always like to pick the easiest one, and so we're going to pick this point right here, 0, 0. So the point 0, 0, I'm going to plug in for x and y in the equation, and we're going to see if this inequality is true. And then I'm going to show you a different way to know if you're shading in the right direction, right? So here we go. First of all, let's talk about the different way first. It's going to make more sense. How would I tell if I'm going to shade below the line or above the line? Well, whenever you say the equation, whatever word you say tells you. So let's read this equation out loud. Y is less than or equal to 1/5 x minus 4. Okay, I'm going to read it again. Y is less than or equal to. Once I say less than, because the less than side is the first side I come to of the inequality sign, then I know less than means shade below. So I'm expecting to shade down here below the line. So that means whenever I plug in this point 0, 0, that point 0, 0 isn't below the line. It is not in the shaded region, so it shouldn't actually work. But let's test it out. We're going to plug 0, 0, 0 for y, and 0 for x, and then we're going to solve this and see if it's true. Okay, 0 is less than or equal to 1/5 times 0. Looks scary, but it's just 0. 0 minus 4. So come down. 0 is less than or equal to, what is 0 minus 4? Negative 4. Is 0 less than or equal to negative 4? Is 0 less than negative 4? Hopefully you say no. No, it's not. Okay, so that means that if I plug in a point and the inequality doesn't work, that means that this point is not in the shaded region, which means the shaded region must be any point on this side. Okay, let's talk about what would have happened if you would have plugged in a point in the right spot. So I'm going to choose a point, I don't know, I already shaded it in, it's all ugly, but there's a point right here, 0, negative 5. Okay, so if x is 0 and y is negative 5. In fact, plug it in and see what happens. I'm going to do it for you in a second. Pause the video if you would. Okay, take the exact same equation, plug in negative 5 for y, and then 1/5 times 0 minus 4. This is why I like using 0, because whenever you multiply, it makes that fraction super easy. Negative 5 is less than or equal to 0 minus 4. Negative 5 is less than or equal to negative 4. Is that true? Is negative 5 less than or equal to negative 4? Yes. So once your inequality is true, you know the point falls within the shaded region. The shaded region literally represents, right, any value in that shaded region is true in the inequality. That's the whole point of shading. The shade means, hey, pick any point in here, and it's going to be true. So go ahead and do this for number 1, 2, 3, and 4. But remember, y is less than 1/5 x means shade down. If I said y is greater than, you already know you're going to shade up. So it kind of gives you a little trick before you even start plugging in values. You know what to expect, right? All right, going down to the set portion. Use the graph to write the inequality that represents the shaded region. Okay, the very first thing you're going to have to do is you're going to have to figure out the equation of the line, and then you're going to have to figure out a couple other things, right? So what do you need to write the equation of an inequality? You need equation of the line, okay, of the line. And I think that most people write it in slope-intercept form. So what's it look like in y equals mx plus b form? Okay, that's the first thing you're going to need. Then, after you find out the equation of the line, is it solid or dotted? Right? You wonder if the line that's on the paper is solid or dotted. Remember, solid is going to look like this, and dotted is going to be like that, right? Whenever you're going to put one of these things in your equation here instead of the equal sign, right? Then you also have to know which way it's shaded. Shaded above or below, right? Above or below. So remember, if it's less than, you shade below. If it's greater than, shade above. So let me give you an example of this. All right, so on the left now you see a line, and it's actually already shaded. And now we're going to do this exact same process here with this line that I created, right? So the first thing this says to do is find the equation of the line in y equals mx plus b form. So what do we need to find the equation? We need the slope, and we need the y-intercept, right? So let's get the y-intercept first. If you come over here to the graph, you'll see that my line is crossing at 0, -5. Okay, so 0, -5. And so we know our equation now is y equals something x, and then here's my y-intercept, so -5, right? Now we just have to figure out what the slope is. And remember, the slope is rise over run. So now that I've found this point, I just need to find any other point. In fact, that's not a good point. It's at the 2.5. Here's a good point. Okay, 2, 1. So how do I go from this point to this point, right? Or here's another point, right? So I'm going to choose the one I found first. Okay, so I go up 1, 2, 3, 4. So I know it's 4 rise. And then once I get there, I run 2, right? I went over 2 to get there. Okay, so once we realize that my fraction's reducible, I got the equation y equals 4 divided by 2 is 2, and I got 2x minus 5. So now I have an actual equation of the line. But now, what do we have to do next? Is the line solid or dotted? Okay, so we can clearly see this line is dotted, which means we're going to have to use an inequality without an equal sign. And then is it shaded above or below? It's shaded above this line, right? So since we're on top of the line, we know that it's going to be y is greater than 2x minus 5. And do we add the equal sign or not? No, because the line's dotted. And now this is my equation. Okay? So just make sure you answer these two questions. Are you solid or dotted? And do you shade above or below? And then you'll know which way to turn the sign. Okay? All right, so get off this. And that's for problem 5, 6, 7, and 8. Once you get to 9, 10, 11, and 12, these ones are all very similar. They just say for each proportional relationship below, one representation is provided. Create the remaining representations and explain any connections you notice. Okay, so number 9, for example, let's change screens, get off this shenanigans. Let's use black. Number 9 says equation, and you don't know the equation. So it says equation, colon. So you need to give me the equation. Then it gives you the table, okay, and then you're supposed to give a graph. Okay, then you're supposed to give a graph. And then it says create a context. Create a context. Okay, so let me give you an example. This is not number 9, but this is exactly how you would do number 9, right? So I'm going to use actually different numbers here. So we're going to say 1, 4, 2, 6, 3, 8, 4, 10. So here's my table that I was given in this random problem, right? And instead of up here, it's going to say hours. and this is going to say dollars. Okay, so maybe I would write a context that said, every day I go to work and I work by the hour, I get paid by the hour, and I make $4 per hour. Okay, and so that's pretty much the context. I earn $4 per hour at my job. Okay, so we're adding not $4 an hour, sorry, $2 an hour. I remember my grandpa used to pay me $2 an hour back in the day to help him work. When I was really young and I thought it wasn't fair, but anywho. So with that being said, $2 an hour. All right, so there's my context. I make $2 an hour to go to work. So every hour I go up $2. Okay, my rise is here. My run is here, right? So here's my rise, here's my run, and that's my slope of my line, which equals 2. So y equals 2x. And if I go back to the 0, even though you think it should be 0, it's actually 2 here. Okay, so remember arithmetic sequences. Go back and look in your notes at arithmetic sequences, because that's what linear equations are. Arithmetic sequences, and you'll have all the notes on this already. I'm kind of going over it fast. Okay, and then last but not least, I'm going to graph it. So I would just graph my points over here. I would just say, okay, 0, 2, 1, 4, 3, 6, etc. And then if you want to draw a line, cool. But that's how you do 9, 10, 11, and 12. It gives you one piece of information and you have to do the rest. This is just like arithmetic sequences. It's kind of bringing them back because that concept's actually very relevant right now. All right, guys, make sure if you have questions, let us know. We'll be happy to help you. Please, please, please ask. See ya.